Imagine you want to buy a car, but you don't entirely trust the seller. You're worried they might not deliver the car after you've paid them. Or maybe you're the seller, and you're concerned the buyer won't transfer the money once they have the car. In a traditional scenario, you might need a lawyer and a lot of paperwork to ensure the deal goes smoothly. This is where smart contracts come in, like a digital superhero in the world of transactions. They're like magic computer programs that make agreements between people trustless, automated, and secure. So in this guide, we'll unravel the mysteries of smart contracts step by step. Contracts everywhere. First, let's get back to basics. What's a contract? It's just a fancy way of saying an agreement between two or more parties. Contracts are all around us. When you buy a house, sign up for a phone plan, or even click I agree to those lengthy software terms and conditions, you're entering into a contract. They can be written or spoken, and they can be as simple as I'll give you $100 for that bicycle, or as complex as a multi-page legal document. Now, here's the problem. In the world of traditional contracts, trust is a big issue. You have to trust the other party to fulfill their end of the deal. In the bicycle example, you trust that they'll give you the bicycle after you hand over $100. But what if they don't? What if they run off with your money and you're left without a bicycle? This trust issue has given birth to lawyers, escrow services, and lots of paperwork, all aimed at making sure both parties fulfill their obligations. It's a bit like having a referee in a game, making sure everyone plays by the rules. Enter smart contracts. Now, let's introduce our superhero, the smart contract. A smart contract is a self-executing contract with the terms of the agreement directly written into code. It lives on a blockchain, which is like a super secure digital ledger that records all transactions. Here's how it works in simple terms. Party A wants to buy Party B's bicycle. They both agree on a price and a set of conditions. Instead of putting their trust in each other, they decide to use a smart contract. Writing the code, a smart contract developer writes a piece of code that embodies the terms of the agreement. It might say something like, if Party A sends $100 to this address, Party B will automatically transfer ownership of the bicycle to Party A. Deployment on the blockchain. The code is deployed onto a blockchain, which is a decentralized and tamper-proof network of computers. Once it's on the blockchain, it can't be changed by anyone. Ethereum. Ethereum is like the granddaddy of smart contract platforms. It was created by Vitalik Buterin and went live in 2015. Ethereum introduced the concept of a world computer where anyone could deploy smart contracts. It uses a cryptocurrency called Ether, ETH, for transactions and to power these smart contracts. Binance Smart Chain, BSC. BSC is a newer player in the game, launched by Binance, one of the world's largest cryptocurrency exchanges. It's similar to Ethereum but designed to be faster and cheaper. BSC also uses its own cryptocurrency, called Binance Coin, BNB, for transactions and smart contract execution. Now, you might be wondering, what's so special about blockchains? Well, blockchains have a few superpowers that make smart contracts possible. Decentralization. Blockchains aren't controlled by a single entity. They're distributed across a network of computers, making them resistant to censorship and tampering. Immutability. Once data is recorded on the blockchain, it can't be changed. This immutability ensures that smart contracts do exactly what they're programmed to do. Transparency. All transactions on a blockchain are visible to anyone. You can see the code and the history of transactions for every smart contract. This transparency builds trust. Security. Blockchains use cryptographic techniques to secure data and transactions. Hacking a blockchain is extremely difficult and costly. Real-world applications. Smart contracts aren't just theoretical. They're already being used for a wide range of real-world applications. Here are a few examples. Smart contracts power decentralized lending, borrowing, and trading platforms. People can borrow money or earn interest on their crypto assets without relying on traditional banks. Non-fungible tokens. NFT are unique digital assets, like digital art or collectibles. Smart contracts are used to create, buy, and sell NFT, ensuring ownership and provenance. Supply chain management. Companies use smart contracts to track the movement of goods through the supply chain. This increases transparency and reduces fraud. Voting systems. Some countries are exploring the use of smart contracts for secure and tamper-proof voting systems. Insurance. Smart contracts can automatically pay out insurance claims when predefined conditions are met, speeding up the process. Limitations and challenges. While smart contracts are promising, they're not without their limitations and challenges. Code vulnerabilities. Smart contracts are only as good as the code they're written in. Bugs or vulnerabilities in the code can lead to exploits and losses. Irreversible transactions. Once a smart contract executes, it's usually irreversible. If there's a mistake or a dispute, it can be challenging to unwind. Legal recognition. Smart contracts are still not widely recognized or enforceable in many legal jurisdictions. Scalability. Blockchains, especially Ethereum, have struggled with scalability, leading to high transaction fees and slower processing times during periods of high demand. Education and adoption. Many people are still unfamiliar with smart contracts and blockchain technology.